Hello, good morning to all. Today we are going to discuss about non-conventional energy sources. So what is the meaning of a non-conventional energy sources? Which are non-exhausted sources are known as non-conventional sources like solar energy, wind energy, water, etc. So why we focus on these non-conventional energy sources nowadays? The reason is the exhaust of conventional sources and the pollution raised by the conventional sources like solar power plants and thermal power plants and electrical generation due to hydropower. So to avoid this power shortage in modern era and focus on green technology and developing a new techniques to eco-friendly, here nowadays we focus on non-conventional energy resources and generate powers from those non-conventional energy sources. In this session we will discuss about two types of non-conventional energy sources. First one is geothermal power and second one is ocean thermal energy conversion. So in this session importance is what is geothermal energy, how it will be helpful to generate electricity, and what is ocean thermal energy conversion, how can we extract or harness electricity from ocean water. And at the end of this session you will know about, get an idea how to generate electricity from geothermal energy as well as in ocean thermal energy conversions. Now let us see what is geothermal power. This geothermal power, the geothermal word taken from Greek language, and this geo indicates earth and thermal indicates heat. So on a overall thing we know that heat taken from earth. On a overall note we understand that heat taken from earth here. And here energy is harnessed, that means the produced from the energy which is inside in the earth is called geothermal energy. This type of geothermal energy mainly we observe it volcanoes and hot springs and some geological conditions area where sulfur ores majorly exist along with water. Where sulfur ores exist along with water, on that places we observe this geothermal power. That means hot water can be observed on a specific locations, especially near volcanoes and hot springs. And these power plants are geothermal power plants are there which can generate electricity from by using run-a turbines from the steam gathered from the geothermal reservoirs. Steam gathered from geothermal reservoirs, and with the help of that steam these turbines will be running and they produce electricity. So these wells are drilled at appropriate locations, that means where we get this energy from the earth, and that mixture of the steam and water is collected at production well. Initially first they drilled a well at that exact locations, and that well is known as production well where we get water as well as steam. And next what to do, we have to separate this steam by using a steam separators. By applying steam separators we separate water and steam. So this steam separators helps to separate steam as well as to run the turbines. With the help of that steam we run these turbines, and finally turbines runs and producing electricity. So again the condensed steam is again enter into production well as well as injected. The term is known as injected, that means after conversion of that steam, and that steam enter into the turbine. When the turbine runs, electricity will be produced. That steam passing out from the turbine and enter into condensed chamber where that steam again converted into water. That water enters into again into the well. That block is known as here injected well. We observe two types of wells here. One is production well and second one is injection well, injected well. Produced well means where we extract steam and water, and injected well is where we supply water into the reservoir. And these geothermal power plants are three types. Majorly we observe three types of geothermal power plants. One is dry steam, and second one is flash steam, and third one is binary cycle plant. So what is the difference between dry, flash and binary? In a dry steam, simply we use steam only. We apply steam, nothing else. We apply only vapors of the water to run the turbine. In flash steam, we apply evaporator. We apply one evaporator which is organic liquid which has low boiling point. So in flash steam power plants, we apply one evaporator chemical that is only organic liquid and which has a low boiling point. And binary means it's a combination of dry plus steam. This is the thing about dry plus steam. It's a combination of dry and steam plants. Now let us see what is dry plant. Just look at this matter, then we will see what happens in this function. So coming to this structure, this is the schematic representation of a dry steam plant. And here what we understand, this is the geothermal reservoir where we observe hot water around the temperature is more than 80 degrees centigrade. In general, nearest volcanoes and hot springs, we observe this type of water reservoirs. And where we incorporated this wells with pumps, one is production well and second one is injection well. So this is the injection well and this is the production well. So two inlets, one inlet and one outlet we observed here. One is production well point and second one is injection well point. So this from this production well, we take up steam into this turbine directly. We supply steam directly into turbine. Here we supply steam directly into the turbine from geothermal reservoir. And this steam helps to run this turbine, and this turbine producing electricity. This turbine produces, run this turbine and it generates electricity. After completion of this process, steam again comes down like this way and enter into the condensation chamber, which is known as condenser, where here steam is converted into water. Condenser helps us to reduce the steam into, that means it reduces their temperature from steam levels to water, that means around 30 degrees temperature. That steam again enter into reservoir through injection well. Through injection well, that water enter into reservoir. So on entire process, we observe that there is no wastage of steam in the reservoir. That means entire water will be circulate in a cycle form. Only we collect that steam and we run the turbine, generate electricity, and finally that steam condensed down into water and transfer to reservoir. Like this way we apply dry steam method. And second method is flash steam method. So this is the most common method nowadays using at geothermal power plants. This is the common method nowadays they are employed. So let us see what is the major conditions for this method. So here this power plant runs around 180 degrees temperature. This is the first important point we observe here. And second one, here steam plus water both are collected and both are separated by steam separator. Both are separated at steam separator. And then that steam is condensed again that means the steam is going the remaining process like flash steam, and it shows the same process. So pressure decreases. So here also, when you decrease the pressure of the water, again this water converted into steam. So at steam separator, what we are doing, we separate steam and water, and that produced water, we decrease the pressure of that water and changes into the vapor. Then that vapor as steam helps to run the turbine. So here, this is the thing we observed that coming to this scheme. So in production well, we observe steam. So in a production well, we are considering steam as well as water, and both are enter into steam separator, and where we separate a steam and a water. Here we separate steam and water by using a steam separator, and some amount of water also converted into steam. As earlier I said, when the pressure decreases of the water, it converted into steam. So the steam helps to run the turbine. The turbine generates electricity, and the condensed steam again become water, which is enter into injection well. So for flash steam, what we observe here, we separate steam and water, and the steam helps to run the turbines for generation of electricity, and the remaining process is same, are similar to dry steam plant. But here the advantage is this is the most using power plant in all over world. And now coming to the third one, binary cycle point. That means it's a combination of dry steam and flash steam, as well as in this power plants we apply hot water from the geothermal as reservoirs, as well as we apply some organic fluid here which has a low boiling point. So let us see what is happening here. So here we take steam and water from production well, and this steam is moving through heat exchanger like this direction. So from the production well we take steam and water, and it is moving to heat exchanger, and from heat exchanger again it enters into injection well. In this heat exchanger here we consider organic fluid, like any type of compound, like any type of gases, methane or chloroforms or etc. Some organic fluids we may consider which have low boiling point substance. When this steam is moving like this way, the substance exists here, it will be evaporated and it become as a vapor or a steam. This steam is moving, and this helps to run the turbine for generation of electricity, and this organic fluid again condense down and enter into again heat exchanger. So here we observe two cycles here. One is water cycle in a reservoir, and second one we observe here moving of organic fluid from heat exchanger to turbine, turbine to condenser, condenser to heat exchanger. So two cycles we observe in a binary cycle plant. In this method also there is no wastage of chemical as well as water of a reservoir. That's about this one, geothermal power plants. We observe three types of geothermal power plants. So after that we will see what is ocean thermal energy conversion. So what is the meaning of ocean thermal energy conversion? On a general note, in any ocean, upper layer and bottom layer. So bottom layer means around 100 feet depth. When you consider this is 0 feet depth. 0 feet depth and 100 feet depth, let us consider like this way. And here the temperature is approximately 25 degrees centigrade. Here it may 4 degrees centigrade. This difference 21 degrees centigrade helps to run the turbine, to generate electricity. So this temperature is minimum requirement for running of a ocean thermal power plant by using a temperature difference, right? So the condition what we understand here, it should be more than 20 degrees or more, and we observe three types of ocean thermal energy conversions. One is closed, known as Anderson. Second one is open, Claude cycle, and third one hybrid. It's a mixture of open plus closed. It's a mixture of open plus closed. So let us see what is the open OTEC. So in this case, we observe two outlets. So first point here, warm water will be moving like this direction. That means upper layer of the sea water or ocean water taken, and it will be moving into the evaporator chamber and again come outside. So this evaporator, where it will be reduce the pressure of the water, it reduce the pressure, where we reduce the pressure of the water and we separate salt content here, we remove salt here, and that steam is moving into turbo generator or turbine to generate electricity, and that water come outside, that steam come outside and enter into condenser. And surrounding of this condenser, we supply cold water. We supply cold water which is from the bottom layer of water. So depth low water we apply here. We apply the low level water for condensation purpose. And after condensation, we observe a product is called desalinated water. Desalinated water, that means salt removed water, we consider like this way. This water helps for agriculture purpose and as well as domestic purpose, not for a drinking one. It can be helpful as a agriculture purpose, for gardening or cultivation, and for domestic purpose. So nowadays in water scarcity countries, the developed countries, they are implementing this type of technology to harness domestic water. And disadvantage is it is a more expensive one, and it requires expensive for degassing and vacuum pumps. So to run this evaporator, we have to implement degassing and vacuum chambers. And next one, closed OTEC, that means closed cycle. We observe a closed cycle here. It is also like binary cycle in geothermal power plant. Like here we observe in this evaporator, we observe organic fluid which contains a low boiling point component. Here warm water from the upper layer will be moving in this direction, and the evaporator in the evaporator chamber is circulating like this way, and here this way we observe closed water moving. So warm water will be moving like this direction, and evaporator is moving as a cycle in this thing. So evaporator starts from here and enter into turbo generator, and again evaporator into turbo generator, from turbo generator to condenser, and again condenser to pump, and again enter into evaporator. That organic fluid moving in a cyclic format, and here cold water is moving through the condenser. So this is the closed ocean thermal energy conversion method. And third one is a mixture of both open and closed cycle. So this method help here. Here organic fluid will be implemented, and here water also come outside as a desalinated water. That means from warm sea water is taken here and enter into the evaporator. So water will be entered into the evaporator, and here this water come out into flash chamber. So sea water enter into flash chamber through the evaporator. Sea water enter into flash chamber through the evaporator. In this evaporator, organic fluid is or low boiling point solution like ammonia moving like this way, like a cycle. So this ammonia helps to run the turbine, and it again comes into evaporator. And here cold water is helps here condense down the ammonia, and again this cold water helps to condense down this desalinated water for collection of desalinated water. So finally here also we collect desalinated water, that means salt free component we are consider in this case. So here today we discuss about two methods, one is geothermal and second one is ocean thermal energy conversion. Okay, so that's it for today. Thank you all.